This video is going to help you fill out section number 3, the bottom flap of section number 3 of your flipbook that's titled Unit 7 Similarity. And this section title is Finding Missing Measures. How do we use the rules or the things we know about similarity to find missing measures? Our essential question is, if I know that two things are similar, how can I find missing measurements? How can I find missing measurements? Now, before we even get into doing a problem class, there's something very important that you have to know, and that is this section right here, the upper left-hand corner. If you want to write that two triangles are similar, you must put the vertex letters in order so that corresponding angles are in the same position. Now, you learned this last year when we dealt with congruence in Integrated Math 1. When you wrote out that two triangles were congruent, you had to make sure that when you wrote it that way, the letters were in the right order so that the vertices that were congruent were in the same position. And in case you forgot that, let's go ahead and go through an example here. For this particular triangle, let's go ahead and label this as, or label the vertices as A, B, and C. Let's label this triangle vertices, these triangle vertices as E, D, and F. You can take a look at these two triangles, class, and let's just say that we assume that these two triangles are similar. Let's assume they are similar. If they are, we need to write our statement of similarity correctly. So let's put here in notes, change this color. Okay, since we know that the measure or angle A is congruent to angle F, take a look at the two triangles. You will see that angle A is 30 degrees, angle F is 30 degrees. Those angles or those vertices match up. And we also see that angle C is congruent to angle E. So angle C is 40 degrees and angle E is 40 degrees. Class, since you know that the interior angles of a triangle add up to 180, we also know that angle B and angle D are congruent, but we don't even need that now. Since you've matched up 2 out of the 3 angles and said those are the angles that correspond to each other, then you would write your similarity statement like this. Triangle A, B, C. Now the order of these letters doesn't matter, but when you write your second triangle, you need to make sure the vertices match up. So since A is our first position here, that means F has to be in our first position here. And since B is our next letter in our triangle name, B matches up to D. So that has to be our next letter. And then finally, C matches up to letter, C matches up to E. So when you look at this similarity statement or similarity notation, you recognize that if I gave you this statement, you know that A and F correspond. A and F correspond. B and D, they correspond. And C and E, those two angles correspond. You must put it in this order, and everything you see in the book and homework and quizzes and tests, if I tell you that two shapes are similar, I'm going to write it in a way so you know which vertex matches up with which vertex on the two shapes. Alright, now knowing that, let's go ahead and do some work. So here's a bottom question on flap number 3. And the statement tells us, if we know that triangle ABC is similar to triangle DEF, then what is? It's going to ask us some questions. What is? Basically, let's find a whole bunch of different measurements from these triangles, or missing measurements based on this statement of similarity. Okay, the first thing I just want you guys to get practice in is how to find scale factor. Now the problem here is that we don't know which of these is the pre-image and which of these is the image. So really we don't know the scale factor, but we can write the two possible scale factors. So let's make a note here. If ABC is the pre-image, if ABC is the pre-image, let me fix that R. If ABC is a pre-image, then remember class, when we do scale factor, it's always going to be a measure of the image over a measure from the pre-image. So now the question is, which measurements do we take? When you do scale factor, just find two corresponding sides that you know the measurement of. And we can look right here, we can see we've got two sides. We've got side CA and side FD. Those are corresponding sides because look at our similarity statement. CA is the third letter and the first letter, and FD is the third letter and the first letter, so that side corresponds. I'm going to circle these to show you that we're going to use that to find our scale factor. So our scale factor is going to be a measure from our image. Well, if ABC is the pre-image, then DEF is the image, so we're going to use a 6 here. That corresponds to side CA, which is 3, and that means our scale factor is 2 to 1. I'm going to circle that. There's our scale factor if ABC is the pre-image. Now, if it happens to be that if DEF is the pre-image, then we got to reverse this process or flip it around. Now we're going to have image over pre-image, and now those roles have reversed. If DEF is the pre-image, then the corresponding side that we know the measurement of is 3. And on the pre-image, that corresponding side is 6. So now our scale factor is 1/2. And you can see, if ABC is the pre-image, that means the image is bigger. It's going to be greater than 1. If DEF is the pre-image, then our image or our copy is smaller, so the scale factor is going to be 1/2. Our scale factor will always be a reciprocal. It depends on which one is the pre-image and which one is the image. So there's our scale factor. Let's go ahead and find some missing measurements now. All right, the first question is, what is the measure of angle B? Well, class, take a look. B, which is in the second position here, corresponds to E. That means whatever B is, E has to be. So, I'm sorry, whatever E is, B has to be. So those two are in the second position. E is 40 degrees. That means the measure of B must also be 40 degrees. Let me write some more information there so you see this. Okay, so since B corresponds to E, then our measure is, so it's 40 degrees. Okay, what's the measure of it? Let's go ahead and write 40 here if we can fit that in. Okay, what's the measure of angle F? All right, we've got to do a little bit of math here for the measure of angle F. And for the triangle DEF, we know this is 90 degrees, this is 40 degrees. We can use the rule of triangle interior angles to find this. To find the measure of angle F, we're going to take 180. We're going to subtract 90 for the measure of angle D. We're going to subtract 40 for the measure of angle E. And that's going to end up with that in your calculator. It's going to be 50 degrees. So the measure of angle F is 50 degrees. I'm going to circle these final answers. Let's go ahead and label that as 50 degrees. And we can also now know, class, because angle F is the third position and it matches with angle C in the third position, therefore if F is 50 degrees, then C is also 50 degrees. So that's easy. That is, we can say that C matches up with angle F. So this value is 50 degrees. So this measure is 50 degrees. All right, how about side lengths? Take a look at side AB. AB, if you look at our similarity statement, AB matches up with DE. DE is 8. So we know that DE is 8. And now the question is, what do we multiply that by? Well, if you take a look at this, if FDE or DEF is our pre-image, our scale factor is 1/2. So we're going to multiply this times 1/2, and we're going to get the value of AB is 4. Okay, let's try to find BC. Take a look at BC. BC is a hypotenuse. Oh, let's go ahead and label this. AB is going to be 4. And actually, that's 4 inches. I should have written here, this is 4 inches. Let's correct that. If we've got a unit of measure, we want to go ahead and specify that. So 4 inches. Okay, let's take a look at BC. Well, BC is the hypotenuse. Man, I can't get that circle right. BC is a hypotenuse. We know the legs, 3 and 4. Let's use Pythagorean theorem to find the missing side. So we've got 3 squared plus 4 squared equals c squared. 3 squared is 9. 4 squared is 16. That means 25 equals c squared. So that means c equals the square root of 25, and the square root of 25 is 5. So BC, let's write that in different colors so we see this. BC is equal to 5. Actually, I'm just going to go ahead and circle this. 5 inches. And I won't put a circle around the whole thing. Let's just put it around our final answer. So we found that by using Pythagorean theorem. So that means BC is 5 inches. Last question is, what's the measure of EF? Well, EF, take a look at your similarity statement. EF matches up with BC. BC is 5. So to find EF, we're going to take 5. Now what are we going to multiply it by? Well, BC comes from the smaller triangle ABC. If ABC is the pre-image, then our scale factor is 2. So in this case, we're going to multiply it by 2. Or let's just go ahead and write 2 over 1 so you know where that came from. And now our answer is 5 times 2 is 10. So the value of EF is 10 inches. And I'll go ahead and label that 10 inches. And now you see, class, we have labeled every side of both triangles. We have labeled every angle of both triangles. And we can do that based on the information given and based on this very important statement, which shows us how we match up corresponding sides and corresponding angles. You're going to find out, class, it's easy with two triangles that are in the same orientation. Once you start twisting them around, trust me, don't try to guess which side goes with which side or which vertex goes with which vertex. Use the similarity statement to match up the different sides and the different vertices to find your missing parts. So let's put a little note over here, by the way, just in this pink so that you guys understand what I did here. So I'm going to put a little note here in pink. Actually, we'll change that to purple. Okay, to find a scale factor, use known corresponding, let's spell that right, use known corresponding sides to find scale factor. All you got to do to find scale factor is find two sides that you know the measurements of, and then use that to find your scale factor. Next video, we'll cover the next part of this section.